Hi everyone, welcome to part 2 of Quant interview questions. I'm quite happy with the response that I got on part 1, and I'm quite motivated to continue this series. In case you have any suggestions for questions, or you have any list of such questions which has previously been asked by Quant firm, please feel free to share the list in the comment section. And yeah, so let's begin with this question. Okay, so the first question is, you are playing a game where an unfair coin is flipped with probability of head. So the coin is unfair as the question suggests, and the probability of head is 0.70, and the probability of tails is 0.30, right? Game ends when you have the same number. Just a minute. So the game ends when you have the same number of tails and heads, right? So as you can see, so it is T and H. So the number of tails and the number of heads are same. So that is 1 1. So the game will end at this point, right? Similarly, T T T H H H, the number of tails are 3, the number of heads are 3, and so the game ends, right? Similarly, if you took a look at the other example, it is H T H, T H H, and T T, right? So the number of heads we have is 4, and the number of tails we have 4 is 4. So the game ends at this point. The number of flips required at this point is 2. The number of flips that is required at this point is 6, and the number of flips required at this point is 8. Now the question is asking, what is the expected number of flips that it will take for the game to end, given that your first flip is a tails? Okay. So the expected number of flips for the game to end if the first flip is a tails. So the question is quite interesting. Okay. So let's start with the basic approach. We have a tails over here. Okay. And now the question is saying that what is the expected number of flip it is required for the game to end. So it is a tail. Let us say the expected number of flip required after getting a tail is EX. Okay. For the game to end. Okay. So then EX would be equal to, the game will end in just one flip, right? If we get a head, right? So 1 into 0.7, because 0.7 is the probability to uh, get head in a flip, probability of getting head in a flip. And one is that if you get a head, then the game ends, right? Because the number of head and tail will be equal. Otherwise, if it does not happen, it will require another some number of flip, right? If it does not happen, it will require another some number of flips, right? So if we get a tail, for example, right? If we get a tail, and so that's not an head, right? So what would happen is that we would require additional number of a step. So what is the number of a step that we will be required is, can anyone, so this is quite important. So what is the number of a step required if you again get a tails, right? So this is quite interesting. So you got a tail and you got a tail. So the number of steps required for this game to end will be EX, and it will again be EX, right? So the total number of steps that will be required from here is 2x plus 1. So it will be 2x plus 1. So I hope you understood the framework, right? So the framework is quite easy. If we get ahead, then it would require just one attempt and the probability of which is 0.7. Otherwise, if you don't get ahead, the probability of which is 0.3 will require some additional number of steps. So we need to find what is the additional number of steps that we will require for that purpose, right? So that should be easy. Why it should be easy? Because we already know what is the number of steps that is required if we get a tail. It is EX. Now we have already got a tail. So for this tail, we'll also require EX additional step, right? Because we have assumed that EX is the number of steps required if we have already a T at some place, right? And then this T also requires one step. So the total number of steps would be 2EX plus 1, right? So if you solve it, let us try to solve this number. It would be EX is equal to 0.7 plus 0.6 EX plus 0.6, right? So 0.4 ex is equal to 1.3, and then ex would be 1.3 divided by 0.4, right? 13 divided by 4. So it would be, are we making something wrong? Let us see it again. Okay, so the mistake is over here. So it should be 0.3. So 0.4 ex is equal to 1. So ex would be 10 divided by 4, which is 2.5. Now, if you take into account the current t as well, right? So t and then the ax, which is one step for the t, and then 2.5. So the final answer would be 3.5. Okay. So let's solve this question. By the way, there are quite multiple approaches to solve these questions. Few of the approaches uses Martingale optional stopping theorem. I will come up with questions using these methods as well. So try using these approaches. So there are very multiple approaches to solve this particular question, because this is quite an interesting one. By the way, if I'm not wrong, this question was asked in Gen Street interviews. Second question is Jim will roll a fair six-sided dice until he gets a 4. Okay, that's good. What is the expected value of the highest number of rolls through this process? Okay, that's good. What is the expected value of the highest number through this process? Okay. So one thing is for sure, that highest number cannot be 1, 2, and 3, because you are stopping only when you get a 4. So the highest number will be at least 4. So the expectation that is required would be 4 into the probability that the highest number is 4 plus 5 into the probability that the highest number is 5 plus 6 into the probability that the highest number is 6. By the way, for this series, while we are continuing, it is the best practice that you pause for a while, try using your own approach, and then try to solve these questions. Okay. Now, let us look at this particular case when we want to find out what is the probability that the highest number would be 4. Okay. So if you look at these 4, 5, and 6, okay. If you look at the 4, 5, and 6, so you expect that this was the combination of 4, 5. So you don't have to worry anything about 1, 2, and 3 and how they are arranged. You want to see how can you arrange 4, 5, and 6, right? So if you look at 4, 5, and 6, what are the possible ways through which you can arrange 4, 5, and 6? 4, 5, 6, 4, 6, 5, right? Let me erase it. So these are the number of ways through which you can arrange these numbers. Then 5, 4, 6, 5, 6, 4, 6, 5, 4, and 6, 4, 5. So there are total 6 approaches, right? So it will be 4 into the probability that the highest is 4 will be in this case, right? So it should be 2 by 6 plus 5 into, note that you don't have to make this street, right? It should be obvious that you can do it by yourself without making the number of possible scenarios. Again, the highest will be 6 in which, what is the probability the highest will be 5? This one, right? And anything else? I don't think so. And then 6 will be highest in 3 cases, right? This one, this one, and this one. So the answer should be simple. 4 into 1 by 3 plus 5 into 1 by 6 plus 6 into 1 by 2. right? So that solves the question. I don't know the exact answer to this question, but you can easily do it. Okay. Let us look at the next question. What number on the die is most likely to appear in the last roll if a fair six-sided dice is rolled repeatedly until the total sum of the numbers rolls reaches at least 9,000? So this is not a question based on probability, but it's a question, a generalized question that maybe asked to see your reasoning or how you know, what's your logic is behind these questions. Okay. So if you see, let us say you are at 8944, right? So if you get a 6, you will easily get 9,000. Sorry, 8994. Otherwise, if you are 8995, if you get a 6, you can cross. If you are at 8996, you can get a 6. 8997, 8998, 8999. So if you see, the if you get a 6, you can easily cross. If you can easily test 9,000 from here, right? But and so if so easily at here as well, at here as well, at here as well, at here as well, at here. But for 5, you will the process will start from here, and for 4, you will start from here, right? So there are higher chances that the last roll will be 6, right? So I hope you understand the logic at least. There are multiple ways to explain this approach. I picked this question, by the way, because this was easy. Okay. So Drax loves eating pizza, but enjoys savoring the slices too. The time it takes for him to eat a pizza slice is uniformly distributed between 1 and 5 minutes. So the time uh, it takes for him to eat a pizza slice is uniformly distributed between 1 and 5 minutes. Okay. So at any time between 1 and 5, Drax can eat the pizza, or the process of eating pizza will get completed. Okay. If he has been eating for 2 minutes and still is not done, find the probability that he finishes the slice in the next minute. So 1 to 2, then 2, 3, then 3, 4, and then 4, 5. Okay. So the pizza eating can be completed any time between uh, this time frame, right? And the prior information that we have been given is that he has been eating pizza till 2 minutes. So so he's still eating pizza. It is not completed yet. So the question is asking, find the probability that he finishes the slice in next minute. What is the probability that the slice will be finished in this minute particularly, which is between 2 and 3 minutes, right? So the question is, find the probability that the pizza will get completed between 2 to 3, given he has not completed he has not completed in 2 minutes, right? This is the probability. So if you know it, just use the conditional probability. So it would be, what do you have to find? Given he has not completed eating pizza in 2 minutes, what is the probability that he will complete within the next minute, that is between 2 and 3? So it should be P in 2 and 3 and P, sorry, right? Divided by P t greater than equal to 2, right? Now let's look at the probability in the down section. So you see, the process of eating pizza can be completed in any of these 4 time frames, right? Out of which 1 time frame has already been completed. So if you see that, what is the probability that this process of eating pizza will get completed between this minute, and this minute? So if framing it in the other way, if you want to frame what is P of t greater than equal to 2, it means what is the probability that he finishes the pizza in between 2 to 3, or 3 to 4, or 4 to 5. Since the probability is uniform, it would be 3 by 4, right? Similarly, what is the probability that it will be completed between 2 and 3? So what is the probability that it will get completed between 2? So this is equivalent to, what is the intersection? The intersection is 2. So what is the probability that the pizza will get finished in this minute, this particular time frame? Since the probability is again uniform, it would be 1 by 4. So it should be 1 by 3. So this problem is easy, but the main part is how you frame the problem, right? And looking at the final question. What is the expected number of draws to get 4 jacks in a row if drags draws from a deck of cards repeatedly with replacement? So there are 52 cards. You have to find the expected number of draws to get J, 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 J. Again, this question is easy, just like you do questions like what is the expected number of trials to get 3 consecutive badge or 3 consecutive tails, just like those approaches, right? So let's do this particular question and try to look at the possible number of ways. So let us say the expectation that of the expected number of draws required is x, right? So now our target is to find what is expectation of x. So let us write expectation of x like this. Okay. So let's make it interesting a bit. How? What will happen if we are kind of getting, excuse me, what is the probability that, in the four, so in we drew the card first time and we got a J. Again we got a J. Again we took a draw, we got a J. And again we do it, it was J, right? So within 4 attempts only, we get the 4 consecutive J. So what is the probability that we do it in 4 attempts only? It will be 4. So this is the this is 4, which is the value of x, one possible value of x, because x can be 4, right? And what is its probability? Obviously, this probability will be 1 by 30 to the power 4, right? Otherwise, what may happen that we have j, 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 but at last we got something else. Let us say we got 3. So now my entire loop has broken, right? So what has happened? The entire loop has broken. So the probability of which happening is 1 by 13 to the power 3 into 12 by 13, right? And what will happen is that I will require additional ex step, which is the expected number of steps to get 4 consecutive j, plus the 4 steps that I have already wasted, right? Ex plus 4. Other way around, what may happen is I may get j and j, and then I may get any other thing at this step. So the probability of it happening is 1 by 13 to the power 2 and 12 by 13. Right? 12 by 13 is that we may get 12 other things, right? Into expectation of x plus, because I may require another ex step from here, and 3 is the number of rows that we have already wasted. So it will be x plus 3. Similarly, if we get j from here, then it would be 1 by 13 into 12 by 13 to the power 1 again, and then ex plus 2, right? And then even the first draw itself is not j, then in that case I will be required 12 by 13, the probability of which is 12 by 13 ex, and only one step has been wasted. So from here we have to solve ex. Okay, so this is the one of the method to solve this particular question. Otherwise you can use Markov chain as well, but the number of states that we have is kind of you can use Markov chain as well. You will be having 5 stages, right? 0, 1, 2, 3, and 4. So if you want to use Markov chain to solve this particular question, maybe you are interested. You will be interested to match your answer. So the answer to this question is 30940. Okay, so that would be your EX. So that's it for today. I took 5 questions previously asked by quant firms. We'll be taking similar questions in the coming series of this particular video. Thank you.